This is going to be part 5 of the series of tutorials for completing our solar system app. And in the previous part, which was part 4, we are now in stage 2. So this is the third part in stage 2, but the fifth one overall in the project. Parts 1 and 2 were stage 1, parts 3, 4, and now 5 are stage 2. So in the previous one, which was part 4, we got as far as step 22 in the guide for stage 2. We tested in Unity, the planets orbited and rotated, and when we press B while the game window is in focus, they still self-rotate, but they stop orbiting. Now, our job is to create a script which will also, if the user squeezes the trigger, to show or hide the canvases, because I don't want to see the text all the time. I want to see it only when we decide to pause the planets and get close to them. So we're going to create an empty game object, call it App Manager. We've done this before. App Manager. It doesn't really matter where it is in the hierarchy. I just, out of habit, like to put it on top. Also, it doesn't really matter in this case its location, but it still looks cleaner if I reset its location. The more important part is that I create for it a script. Attach a new script to it called Solar Manager, and make sure to move the new Solar Manager script into my scripts. And of course, you're going to type this manually, which of course you can do by pausing the video right now and looking at the written guide. I'm just reminding you that if you select the object and add component and add script like that, when you save, it'll ask you, or it used to put it by default, but now it'll ask you what folder to put it in, and you're going to put it into the folder My Scripts, which I already did. So that means that it would look something like this. So here's App Manager with the Solar script attached to it with all those game objects to be specified. But let's go over the code. I'm going to open the Solar Manager. It looks like a longer script, but it really isn't, because a lot of it is just repetition. Let's look at it. Using Unity Engine, the simplest library. And then we're declaring basically all the objects that have a canvas. A bunch of game objects, Mercury display, Venus display, Earth display, all of these are supposed to represent all the canvases to be turned on or off when the user squeezes the trigger. And then the rest of the script is update. There is no start. During update, there's two parts. If the user squeezes the trigger, if the user does not squeeze the trigger. If the user squeezes the trigger of the left index or the right index, or B, we've made it listen to it before, but now we're just making it perform something else. This is a leftover from the time I developed this. I wanted to make sure that it senses it, so I made a print, but now I commented it out. I'm just going to tell it, hey, if the user is squeezing the trigger, Mercury display, set active true. Venus display, set active true, and so forth, and so forth, and so forth. In other words, set all the canvases visible if the user presses the trigger. And that way, it also pauses each planet, and we can get close to it and read. But when the triggers are not pulled, which is most of the time, in other words, this raw button is not pressed, and this raw button is not pressed, and the B key is not pressed, then all the canvases will be set to active false, which means they will be turned off. They're still there, but they will be turned off. They will be invisible. That's the end of the if, end of the update, and end of the class. The important thing is that once we do that, we're going to have to populate all the public fields, tell it, okay, what's the Mercury display, what's the Venus display, and so on. Make sure you populate them with canvases, not the planets themselves. We don't want to hide the planet, we just want to hide the canvas of the planet. So what I'm going to do is this. App Manager, and I'm going to start carefully dragging Canvas Mercury to Mercury display, and Canvas Venus. This is why it was important to name them different names so I can tell them apart. And Canvas Earth to Earth display, and Canvas Moon to Moon display. I hope I'm not missing any of them. Canvas Mars to Mars display. Again, I'm not dragging Mars, I'm dragging the canvas Mars to be shown or hidden. The Jupiter canvas, and from the Saturn container, I should be able to find the canvas Saturn for Saturn display, the Uranus display, and the Neptune display. Now they're all populated. What does that mean? That when I play, right now, all the canvases should be invisible. I see the planets. Here they are. Let me make the game window bigger. What I can even do is change it from play focus to play maximized, which will fill up the screen. And I can see all of those planets moving, but there's no canvases. But if I press B, two things should happen. They should stop orbiting and show their canvas. Orbit and not show, not orbit and show. That way, if this was a real game, I could also fly towards them and see them. So there's only one thing left. Do you see how, because the planets are still self-orbiting, so does the canvas? I want to make sure that the canvas not only does not rotate, but actually rotates itself towards me. So it's always readable. When I'm getting close to Neptune, I want the text of Neptune to always face me. And this is going to be the last step in our application. So if this works, we can go to the last step of our application. So we just tested number 27. We played. Planets should rotate. Canvases should be initially hidden. When pressing and holding B, planets should be orbiting, still self-rotating, and canvases show up. When releasing B, the planets resume moving. If that works, in my scripts folder, we're going to right-click and create. We're not attaching it to a specific object because we're going to attach it to all the canvases. So we're creating it independently. It's a very, very short script. It's called look at. And it's a script that whoever you attach it to, you can make it look at a specific object, orient itself all the time towards a specific object. So again, I'm assuming you're going to pause right now, create a script called look at, type this code instead of the default code. And I'm assuming that if you're hearing my voice right now, you already did that. And here's the script called look at after I already typed that very minimal code. It's like, less than 20 lines. Let's see what it does. It has only one public. Notice it's not a game object, but a transform. Transform means a location. It's like, okay, I'm, let's say, the canvas of Neptune. Who do I need to look at all the time? Update, which means 72 times a second, it's going to check. What is the position of that target? What is its X? What is its Y? What is its Z? And the target position will be target position X. It's going to not take the position Y from the object that it's looking at, but from itself. This dot transform position Y. In other words, I want it to stay upright. In other words, if the target goes left, I want it to rotate left. If the target goes right, I want it to rotate right. If the target goes away from me, then, whatever. But I do not want that canvas to bend forward and back. I want it to stay upright so the Y is still taken from the object itself. Then the function itself, transform.lookAt target, and apply all those values. In other words, look at what, the sun. What is the sun's X? What is the sun's Z? You need to look there. Then this .transform.lookAt target position, actually apply it. So in other words, this calculates it and this applies it. And this does one more little thing. It says, well, now that you're looking at it, I actually want you to look back at it like a mirror. So it goes, there's one more thing I need to do to your rotation. Quaternion, Euler, transforms rotation into regular degrees from Euler degrees. And it says, okay, now that you rotated, I don't need you to change the X rotation. I don't need you to change the Y rotation, the Z rotation, but your Y rotation will be 180 because if you don't, the canvas will face away from the sun instead of towards the sun, away from the camera instead of towards the camera. So it's basically, I want you to turn around and face me. That would be the comment that I would add. Turn around and face, in this case, the camera. Now, we need to attach this script, as the instructions are saying. We need to attach this script to all the canvases. Select all the canvases. So I'm going to carefully unfold everything and select all the canvases, and once all of them are open and selected, I'm going to drag the script to all of them. Let's do that. Of course, I can do it one at a time, but I think it'll be easier to do it all at once. So again, carefully, I'm selecting Canvas Mercury. On Mac, I'm holding Command. On Windows, it'll be Control, and Canvas Venus, and Canvas Moon, and Canvas Earth, and Canvas Mars, Canvas Jupiter, Canvas Saturn, not the sphere, not the ring, Canvas Uranus, and Canvas Neptune. All my canvases are selected. Once all my canvases are selected, I can take the Look At script and attach it to all of them. And the only thing I need is to, again, make sure that they're all selected. I might have to do it again. Jupiter and Saturn. I'm making sure that I'm selecting only the ones that are real canvases, not the planets themselves. And once all of them are selected, I'm going to take the OVR player controller and drag it to be the target. I'm telling all of them, hey, what you need to look at is where I am. So I'm flying left, you rotate towards me, of course, facing me. That's the 180 degrees right here. So if we look at so we just did step number 31. While all the canvases are still selected, populate the target field with the OVR player controller. It populates all the canvases selected. So what should happen now is if I play, planets should rotate and canvases should be initially hidden. But when I press and hold B, planets should stop, canvases should show up and rotate to face the camera. How can I see that even before I build? What I can do is look at it from above, let's say from the point of view of the sun. I can look at it from above. I can turn on my gizmos. This shows me the orientation of the canvases. Look at what happens when I play. My camera is right here. This is my camera. When I play, I want to make sure I'm not playing maximized. Play focused. Because in this case, it's easier to look at the scene. When I play and I hold B, look at where the canvases are rotated. This one towards me. This one towards me. This one, this one. When I let go of B, I'm holding B right now, and let it keep rotating. At any point when I hold B, all the canvases are pretty much arranged around me. Now, the other cool thing to do is maybe to take the OVR player controller using the move tool. And this is playing, and I'm holding B. And as I'm moving, I'm like simulate, oh, what will happen if I fly here? And I'm pressing the, see how all of them are oriented towards me. Of course, when I stop, I want to make sure that the OVR player controller has returned to 0, 2 meters above ground, and negative 20. In other words, 20 meters backing up from the sun. So, and this is really the end of the application. This is it. If that works, we're going to just add one more little, atmosphere thing, which is a game object called music. We're going to add an audio source and assign the audio resource, Solar Music 24A, as the audio clip. We're going to make sure it loops. We're going to make sure it plays on awake, but we don't need it to be too loud, so volume of 0.8 I found to be just fine. And this right now, if you have access to Quest, great. If not, we're going to build it in class and zip the entire project and submit. Also reminding you that if the project zipped is too big to be submitted in your course shell, then take out the library and only the library and zip again, and it should be much smaller. So let's add the music. So I'm going to add an empty game object. I'm going to make sure it's reset. I'm going to call it music. To that empty game object, I'm going to add the component audio source. And the only thing I'm going to do is use the audio resource space ambient music. Let's see if it's the right one. Yep. I'm going to change the instructions to have the right name. Good. And I'm going to make sure that it plays on awake, that it loops, and that the volume is 0.8. That's it. That was the end of part 5, which is also the end of the series of videos for constructing the Solar app.